Hello class ninth. Today we are going to study science, CBSE board. The unit 1 of this science book is matter, its nature and behavior. And the chapter 1 is matter in our surroundings. So let's get started. The contents of this course will be what is matter, the physical nature of matter, the characteristics of the particles of matter, the states of matter, and can matter change states. So, in the years of 1990s, there used to come a cartoon by the name Captain Planet on the channel Cartoon Network. In that cartoon, there were five friends who had different kinds of rings in their hands, and those rings had different kinds of powers. So, when these friends were in any kind of trouble, they used to combine these five powers, which gave birth to Captain Planet. And Captain Planet used to help them from all their enemies against the troubles. Those five powers in the rings were air, earth, water, fire, and sky. Now you might be thinking, while studying matter, why am I telling you about this cartoon? Actually, this cartoon is very important for matter. The older days scientists used to believe that this whole universe is made up of five basic elements, and those basic elements were air, earth, water, fire, and sky, which they used to call as Panchatattva. When the studies moved forward, now science has defined a new word for the whole constituents of the universe. The word is matter. Yes, everything in this whole universe is made up of matter. The water, the air, the trees around us, we, the human body, are things which we own, the stone, and everything which you can count upon is made up of matter. Let's move forward. The course learning objectives are to explain the composition of things around us, demonstrate reasoning for different processes related to the change of states of matter, and to link the theoretical concept to the practical life for better understanding. Now let's see the learning outcomes of the course. At the completion of this lesson, you will be able to define and explain matter and categorize its type. You will be able to identify what matter is made up of and analyze the change of different states of matter. You'll be able to differentiate different kinds of phenomena which take place related to matter states. You'll be able to describe evaporation process and relate chemistry to your daily life. So let's start the chapter. What is matter? How can it be classified? As you know that everything in this universe is made up of matter. The air you breathe, the food you eat, the stones around us, that table, that chair, the mobile phone, the laptop which you are using right now, the clothes which you are wearing, the sun, the moon, everything around us is made up of matter. But how do we define matter in our science? The definition of matter is very simple. It says that matter is anything which has mass and occupies space. It deals with the weight and the volume. So think now. All those examples which we are seeing right now, do they have weight? Yes, they all have weight. And do they occupy some amount of volume? Yes, they occupy some volume. So now let's see the classification of matter. Matter has been classified on the basis of its physical nature and chemical nature. In this chapter, we will be focusing on the physical nature of matter. So, I'll ask you some questions now. Pouring salt in water makes the whole glass of water salty. Why? Just a small pinch of color makes the whole bucket of water colorful. Have you ever seen sand? What is it made of? All these questions have one single answer. The answer is particles. Yes, matter is made up of extremely small particles. Now focus on this diagram. It is a diagram of a wall having different brown colored bricks. These bricks are the building blocks of the wall. In the same manner, the particles are the building block of matter. Now, these particles of matter have spaces between them. So, we'll go back to the previous slide. So, when we pour a pinch of salt in the water, the salt particles go in the spaces between the water particles. Now, focus on my hand. My left hand is having spaces between the fingers. And in those spaces, these fingers are coming in. In the same manner, the particles of salt go inside the spaces between the particles of water. In the same manner, the particles of the colored powder are going inside the spaces between the particles of the liquid in the bucket. Also, you will see that the particles of the matter are continuously moving. That means they have kinetic energy. Let's understand this with the help of an example of the incense sticks. When we light these agarbattis in our room, they spread the aroma in the whole room. How is that happening? It is happening because the particles of the smoke are moving continuously and they get spread in the whole room. Also, let's take example of sugar being mixed in milk. When we heat the milk, the same amount of sugar gets absorbed and mixed in this milk fastly. Why is that happening? That sugar is mixed faster in milk on heating. It is because as we increase the temperature, the particles start to move faster because they absorb the heat energy. So now when the milk is heated, the particles of the milk start to move faster and they create more space in between them for the sugar particles. So we have learned that with increase in temperature, the kinetic energy of the particles also increases. Now let us see some interesting examples to understand the next property of the particles. Have you ever tried to do this? That is, to try to cut the stream of water with the help of scissor? And have you ever tried to break these three things, rubber band, chalk and a nail, with the help of a hammer? You'll be able to see that it is difficult to break a nail and a rubber band, but the chalk breaks easily. But then too you have to apply some amount of force and you won't be able to cut the stream of water. That means that the particles of this water are holding each other with some kind of attractive force. The particles of the nail are holding them with a very strong attractive force because of which you are not able to break it. And in the same manner for rubber band and chalk. So we come to know that the particles hold each other with an attractive force which is acting between them. The states of matter. Now as we said that we are going to classify matter based on the physical nature in that chapter, we are going to learn about the three states of matter, namely solids, liquids and gas. As you can see in the diagram we have made, solid, liquid and gases. So let's see more about it. The first state which we are going to learn is the solid state. Can you see a chair? Can you see that this chair is having a fixed definite shape, a definite volume, and you can see the boundaries of the chair being fixed. This is the definition of a solid. Solids have definite shape, fixed volume and distinct boundaries. And also, it is difficult to change their shape. They are rigid. Can you change the shape of this solid without breaking it? No. That means that this is rigid. Also, we cannot compress solid because they may break under outside force. So without breaking, it is difficult to compress a solid. Now, let's move to the liquid state. So, examples of liquid, the best example is water, milk, a soft drink and different juices. So let's observe about liquid. Liquids have no fixed shape. They take the shape of the container in which they are kept. You might have poured liquid in different kinds of vessels. As you can see in the diagram, the liquid has been poured in three different kinds of vessels and it is taking the shape of the container. That means they have no fixed shape. It also means that they are not as rigid as the solids. Also, liquids change their shape and they can flow. You might have seen liquid flowing in a lot of examples, and that is why they are called fluid. Also, the particles of the liquid move freely. They have greater spaces between them as compared to solids, and that is the reason that solids cannot flow and liquid can flow. There are spaces and because of which different solids and gases dissolve inside the liquid. Now let us understand about different kinds of solids and gases dissolving in the liquid. Sugar and salt are the example of solids. Do they dissolve in milk and water? Yes, they do. Now let's see an example of gases dissolving in liquids. You know the fishes and the aquatic plants which live under the water? How do they breathe? Have you ever thought? They also need oxygen and carbon dioxide. How is that oxygen and carbon dioxide reaching inside the water? It is because these two gases, carbon dioxide and oxygen, are getting mixed with water, and that is why they are able to take it from the water and live life. Also, sugar solution, oxygen, carbon dioxide, they all get mixed in water. Now, the third state of matter is the gaseous state. As you can see, that you have seen an example of incense stick and the aroma and the smoke coming out of it. In the same manner, you cannot see air but you can feel it. Air is the best example of a gaseous state. So what we have observed that gases have no fixed shape. They fill the whole container in which they are kept. And also they can change their shape. Actually they have no shape of their own and they can also flow. And so gases and liquids both are called fluids. As compared to liquids, the particles move more rapidly and have greater spaces between them as compared to solids and liquids both. Also, gases can be compressed. The example which we can see is LPG, CNG and oxygen cylinders. You know LPG gases which comes in your home, in your kitchen, that is the cooking gas. It is actually a compressed gas put in the red colored container. Also in hospitals, there are oxygen cylinders used. The gas inside that is compressed oxygen. And you might have seen many vehicles running on CNG fuel. That CNG is compressed natural gas. These all give examples that gases can be compressed. In the same manner, you might have imagined that when your mother cooks a very delicious food in the kitchen, the aroma of that food comes to you inside your study room. How is that happening? The aroma of the food is mixing with the air around it and it is moving faster and diffusing to come to your nose. So, the particles of the gas diffuse very fast into the air and the gases are highly compressible. Also, the particles of gas move very fast, hit each other and exert some amount of pressure in the walls of the container in which they are kept. Till now, you have studied about three states of matter. And those are solid, liquid and gases. Now let's move forward and ask these questions. Can a solid change into gas or liquid? Can a gas change into liquid or solid? So, can matter change states? So we can think about these questions. Have you ever seen ice melting to form water? Have you ever seen water boiling to form vapor or steam? I think you all have seen these processes happening. How is this process actually happening? In the image in front of your screen, you can see a man is throwing a jug full of water in the sky and this water is all of a sudden converting into snow. Isn't that amazing? It actually makes us curious that how these processes are happening. So let's move forward and understand the change of states of matter. Now in front of your screen, you can see the example of solid, liquid and gas in the form of ice, water and water vapor. So with this basic example, we will understand that how the states of matter are changing from solid to liquid and then to gas. Before moving further, I would like to ask you a real life question. When you eat your food, you get energy. And when you are energetic, what kinds of work do you like to do? Do you like to sit and relax? Or do you like to run and play and do different kinds of activities? Think about it. When we all are energetic, we do different kinds of work involving motion. We move and do a lot of physical activity. In the same manner, think yourself as a particle of a matter. So when that particle is having high energy, it will vibrate at higher speeds, and because of which we call it having high amount of kinetic energy. With this basic principle, we will proceed further to understand this example of change of states of matter. So please focus in the diagram. You can see we have a magnified image of the particles inside the solid, inside the liquid and inside gases. You can see that the distance between the particles is the least in solid and maximum in gases. Now, we will start to heat the solid, because of which the temperature of the solid will increase. And as we are giving this heat energy, the particles will start to vibrate at higher speeds. And also the temperature of the solid will increase. And this process will go on to a point when, if you remember, that there were attractive forces acting between the particles of the solid, there will come a point when this energy supplied will overcome this attractive force, and because of the high amount of vibrations, these particles will leave each other. and increase the distance between them. So they will start to move freely, and when they start to move freely, they show the properties of a liquid. So the specific temperature at which the solid starts to change to liquid is called the melting point of that solid. This process in which a solid changes to liquid is called the process of fusion. But we noticed one very special phenomena when the solid is changing to liquid. It was observed that while heating solid to liquid, the temperature was not changing at the point of fusion. That is, when solid was actually changing to liquid, the temperature remained constant. And you know what that temperature is? That is 0 degrees Celsius. At 0 degrees Celsius, the heat which we were giving to solid gets converted to liquids, but it does not show any temperature change. So where is that heat going? That heat is getting hidden in the container, or it is actually getting used to change the state of solid to liquid. So that hidden heat is called the latent heat of fusion. And please note, for ice the melting point is 0 degree centigrade or 273 degree Kelvin. Now let's move further. Now we have liquid and we are going to supply heat to this liquid. Now as we supply heat to this liquid, the particles will increase their kinetic energy and will start to move further from each other with increased speed. And because of which there will come a point when the energy supplied by the heat will overcome the attractive forces acting between the liquid particles. Now as these particles, they will start to break free from the upper surface of the liquid. And when they break free from the upper surface, they become gases. So this point of temperature when liquid starts to convert into gases is called the boiling point of that liquid. And this process of the conversion of liquid to gas is called vaporization, because the liquid is converted into water vapor in the case of water. So in this also the same process happened. During the process of the conversion of liquid to gases, we have seen that the heat is not increasing any temperature. So where is that heat actually going? The heat is actually getting used to convert liquid to gases. So this hidden heat is called the latent heat of vaporization. And please note that the boiling point of water is 100 degrees Celsius or 373 Kelvin. Now you might have observed that the solid gets changed to liquid and the liquid gets changed to gases. So this was the basic understanding of how this process is actually happening. Now, after understanding the process of fusion and vaporization, we are going to look into some special processes. So, have you seen a camphor or kapoor? When you burn a kapoor or camphor, it directly changes into gases. So it is an example of sublimation, the process in which a solid directly changes into gaseous state without getting changed into liquids. Similarly, there is a special process called deposition. In the colder countries, the window panes get collected by snow. So that snow on the window pane is directly a solid state which has been converted from the gaseous state. Without the gases getting changed into liquid when changed to solid state, that process is called deposition. And now comes condensation. The basic explanation and an example of condensation is the rainfall. When gases change to liquid on cooling, it is called condensation. So till this point, we have studied the change of states of matter based on the change of temperature. But we come to know that matter can also change states due to pressure. Now let us understand this phenomenon. Effect of pressure change on the states of matter. So we come to know that by applying pressure on the particles of matter, they can be brought together. Visualize this example. The gas was having particles at far distances. Now if you apply pressure on these particles, they will come close, and if they come so closer that in a moment they will form liquid, and if we apply more pressure, they will turn to solids. So having this same concept as an understanding, we studied that pressure and temperature both determine the state of substance, whether it will be solid, liquid or gas. As you can see in the example, there is a piston and a cylinder, and inside the cylinder we have gaseous particles. When pressure is applied by the piston, the particles come close to form liquid, and now on applying more pressure, it will eventually get converted into solid. What is a good example to understand the pressure change on the state of matter? You know what is dry ice? Dry ice is solid carbon dioxide. solid carbon dioxide is kept in a pressurized can and it is in solid state. And as soon as the pressure containers are opened, it directly converts into gaseous state. That means the solid CO2 was stored in a pressurized condition and that is why it was solid. And as we opened the can, the particles started to move further away. So this is a good example of the pressure change effect on the changes of states of matter. Now, because of pressure and temperature, the states of the matter change. But we are going to study a new process which does not need the application of heat or temperature. Do you know how clouds are formed, how your clothes are dried, and how when a water is left uncovered becomes vapor? The answer to all these questions is evaporation. Evaporation is the process in which the liquid particles at the surface of the liquid break away from the attractive forces which was holding them together to become vapor. Evaporation is somewhat like vaporization only, but in this process it is happening below the boiling point. So, if you note what was happening in vaporization, let me take you back to that slide. In the process of vaporization, the liquid was converted to vapor at boiling point. And what was the boiling point for water? At 100 degrees Celsius. So at boiling point, when liquid converts into gases, we call it vaporization. But in case of evaporation, the liquid is converted into gaseous state below the boiling point. This process is called evaporation. Let us understand more about this process. And in this image, you can see a new invention in our own country, India. Some people have developed an innovative air conditioner that is made of mud. What is the concept being used? How is this vessels of mud creating a cool air? Let us understand. So, the answer to that process of air conditioner made of mud lies in this slide. Evaporation, its rate and effects. So now we understand that the evaporation is based on the 4 points, and those are exposed surface area, the temperature of the surface, the humidity in the surrounding air, and the wind speed. Let us take these points one by one. Have you ever had tea in a saucer and a cup? So we pour the tea in the saucer and it gets cooled fastly. You know why that is happening? Because the surface area of the tea is getting increased, because of which it is getting cooled down faster. And if the temperature of the surface is high, then it will evaporate more fastly and the liquid particles will leave the surface and get converted into vapor. Now we talk about humidity. Humidity is the amount of moisture or water vapor content in the surrounding air. If the surrounding air is having low amount of moisture content, then it will take away the moisture or the water vapor from the liquid, and so more evaporation will be seen. And also, if the speed of the wind is high, you might have seen that your clothes, they dry fast when the wind is blowing at higher speed. So these are the 4 points on which the evaporation rate depends upon: the exposed surface area, the temperature, the humidity of the surrounding air, and the wind speeds. You might have observed that when the sweat evaporates from our skin, we get a cooling sensation. Why is that happening? And you might have also seen that when you pour acetone, nail polish remover, or spirit on your hands, it gives you a cooling effect. Why is this happening? This is happening as a result of evaporation. When the liquid on the surface evaporates, it takes away heat from the surface and converts into gases. So because of which it produces a cooling effect. Here lies the answer for the air conditioner made of mud. In these containers, evaporation is happening, because of which the air which is being hot gets transferred into cool air because of the evaporative cooling effect. So we come to know that liquids absorb heat from the surrounding to evaporate it and give a cooling effect. Now, we have learned a lot of good concepts. Now let us see at some important words and their definitions, which we have seen in this chapter. The first one is particles. Particles are the building blocks of matter. Visualize the example of the brick inside a wall. Now, the second word is density. Density is the mass per unit volume of a substance. And the formula for density is mass upon volume. Rigidity. You might have seen this example and this word being used when we were studying about solids. So rigidity is the property of matter to maintain its shape. The chair on which you are sitting, your laptop, your phone, they all are rigid. They all have fixed shape. The example is solids. Now let's move to the other word, that is compressibility. Compressibility is the ability of a matter to get compressed. Can you compress solid? No. But can you compress gases? Yes. So the property of matter to allow compression under high pressures is called compressibility. Now we move to the other word, that is fluid. Any substance which can easily flow is called fluid. It can change its shape under external forces. What are the examples? Liquid and gases. The next word is kinetic energy. I hope you have understood this word very properly. So kinetic energy is the energy present in an object when it is under any kind of motion. So, question 1. Convert the following temperatures to Celsius scale. The two temperatures given are 300 Kelvin and 573 Kelvin. So let us understand the concept to solve these kinds of questions of conversion of temperature scales. See, there are two basic temperature scales which we come forward in, centigrade and Kelvin. In the centigrade scale is that scale of temperature which we used in thermometer to measure our fever. You might have seen those kinds of thermometer. So in that, the freezing point of water is 0 degrees centigrade and the boiling point of water is 100 degrees centigrade. But when we see these temperatures in Kelvin, they give the value 273 Kelvin and 373 Kelvin. So this is giving us a relation between the Celsius and the Kelvin scale, and that relation is that the value of Kelvin scale is equal to 273 plus the value of the Celsius scale or the centigrade scale. So now let us try to solve the first question. The value of the temperature in Kelvin scale is 300 Kelvin. So degree Celsius will be converted into 300 minus 273, which will give 23 degrees Celsius. In the same manner, when we put the value of K as 573 for the second question, we get 573 minus 273, that gives 300 degrees Celsius. That means 300 Kelvin is equal to 27 degrees centigrade in the Celsius scale, and 573 Kelvin is equal to 300 degrees centigrade in the Celsius scale. Now move to question 2. What is the physical state of water at these two temperatures, 250 degrees centigrade and 100 degrees centigrade? Observe closely. We are talking about the physical state of water. 100 degrees centigrade is the boiling point of water. That means above 100 degree, the water will be in which state? It will be in vapor state. So in both these temperatures, 100 degree and 250 degree, the water will be found in vapor state. What we will have? Water vapor. So 100 degree is the boiling point of water above which water is in gaseous state. So at both these temperatures, water is in gaseous state. That is water vapor. Now let's move to question number 3. It is about the food which you are eating in your homes. The smell of the hot, newly cooked, sizzling food reaches to you several meters away. But to get the smell of cold food, you have to go close to it. Have you observed this phenomena? So this question is wanting you to see and understand that why this is happening. So let us see what the reason is. See, since the hot sizzling food has temperature higher than the cold food, because of which at higher temperature, what will happen? The particles of that food and its smell and aroma, those particles will move faster, and when they will move faster, they will have high diffusion rate, high movement, high kinetic energy. So because of that kinetic energy, these particles get very fastly diffused with the air and they reach several meters away to us. But in case of cold food, they have lower energy, because of which we have to go close to smell the aroma of that food. Now let's move to the next question. Question number 4. It is also like question number 1. We have to convert the following temperatures to Kelvin scale now in this case. The two temperatures given are 25 degrees Celsius and 373 degrees Celsius. So the same formula will be applied. Kelvin equals to degree Celsius plus 273. Putting the values as 25 degree, we get 298 Kelvin. And again putting the value as 373 plus 273, we get 656 degree Kelvin. So we see that the value of 25 degree centigrade is equal to 298 degree Kelvin, and the value of 373 degree centigrade is equal to 656 degree Kelvin. Now this is one of my favorite questions, because this is going to test all your knowledge. Till now, whatever you have learned, this question is going to test everything. So let us see. Name A, B, C, D, E and F in the following diagram showing the change in its state. So we are seeing that solid, liquid and gases are mentioned, and they have mentioned that in this direction the heat is getting increased and the pressure is getting decreased, and in this direction the heat is also getting increased and decreased. So A, B, C, D, E are the different processes. So let us focus on process number A. What is happening? Solid is getting converted into liquid by application of heat. Remember, when solid converts into liquid, what is it called? It is called melting or fusion. Okay, now move to B. In B, the liquid is converting into gas. If you remember, we have studied this in the change of states of matter. This process of converted of liquid into gas is called vaporization. The liquid is now converted into its vapor form. Now the process C, in which the gas is getting converted into liquid. Is that what happens when the rain falls? The clouds get converted into rain. So what is this process? This process is condensation, the process of cooling and the conversion of gas into liquid. Now let's see process number D. When liquid changes into solid. Is that what is happening inside the freezer of your fridge? That water which you keep in the ice trays is getting converted into the ice, the solid. So what is this process? This process is freezing or solidification. This also happens because of cooling. Now let us go to the process number E. E is the special process which we mentioned about that camphor, that kapoor, when solid directly changes into gas. This process is called sublimation. Okay, so these were the processes, and now let's move to the next process, that is when gas directly changes to solid. This process is called solidification or deposition. So students, till this point we have covered all the basic concept of this chapter, matter in our surroundings. We have also covered different kinds of examples and understood different various phenomena of changes of states of matter. We have also covered evaporation. Now, after gaining this much amount of knowledge, it is very necessary to go through the application part and to try to answer the questions which are frequently asked in your board examinations. So let us move forward and understand this question and try to answer them. Question number 6. How sublimation is used in everyday life? So, sublimation is the process of the direct conversion of solid to gaseous state without getting converted into liquids. We have seen that in everyday life in these examples of camphor. When you burn a kapoor or camphor, it directly changes into gaseous state. Inside the bathrooms, we use these air fresheners. These washroom air fresheners are actually solid, and with time they get sublimated and convert into gaseous state, because of which they keep the washroom having a good smell. Also, another example of sublimation is the naphthalene or the mothballs, which are used to keep the insects away from the old winter clothes when they are kept inside a box for a long duration of time. These are some basic examples of sublimation being used in our everyday life. Can you find more examples for yourself? So let's move to question number 7. What is the state of interparticle distance inside a solid, liquid and gas? So let us understand this with these diagrams. And I guess you already know the answer, but let us focus. In solids, the particles are actually very tightly packed and very close to each other and are bonded by strong forces of attraction. So their interparticular distance will be least. Now when we move to liquids, the particles are a little far away in comparison to solids. But they are also bonded by some kinds of weak but attractive forces. So the interparticle distance is larger as compared to solids. Now we come to gases. In gases, the particles are very far apart. from each other and are bonded by the very weak attraction forces. So, the interparticle distance is the largest in case of gases. Now, let's move to the next question. Question number 8. How does evaporation cause cooling? Now, we have to answer about the evaporative cooling. So, when a substance evaporates to form vapor, it is actually absorbing heat from that surface from which it is evaporating. And when it takes away the heat, obviously the surface will get cooled off. Some good examples to understand this is when we sweat, we feel a cooling sensation. The matka or the earthen pots which is used to keep the water cool. You know how it is keeping the water cool? Actually, the matka or the earthen pot is having very small pores. And from those small pores, the water is seeping out. And that water which comes out from those pores gets evaporated. And when it gets evaporated, it takes away with it the surrounding heat, because of which it gives a cooling effect. And you might have also heard that during dry, hot summer conditions, we should wear cotton clothes. The cotton also acts in the same manner like this matka. The cotton allows the sweat to get converted into the surface area, and on that surface area, the liquid form of sweat will get converted into vapor state. So, because of which it is said that cotton should be worn on the dry summer and hot conditions. Next question. Question number 9. Give an experiment to show that ammonium chloride undergoes sublimation. So we have an experimental example to understand sublimation. So this is how the experimental example goes on. Take an inverted funnel and inside it take a china dish in which we will keep the crystals of ammonium chloride. So the ammonium chloride crystals are kept inside an inverted funnel in a dish. So now when we start to heat these crystals with the burner, these crystals will take up this heat, and we observe that the vapors of ammonium chloride are seen getting off from this ammonium chloride crystals. And also we see a solidified ammonium chloride along the walls of the funnel at the end of the beaker. So what is it showing? It is showing that the solid ammonium chloride does not change into liquid state. That means it is directly changed to vapor state, which in terms solidified. That is, it goes sublimation. So solid changes directly to gases without undergoing liquid state. So these were the basic questions to understand the process of change of states of matter, its different definitions. So this was the course for chapter 1. We are done with the chapter 1. Now you can read your NCERT book and you will get understanding of each and every activity and examples. And the CBSE has designed a very good course to give you a basic understanding of the basic laws which govern the chemistry of the matter. Thank you.